Hello everyone. So in today's data structure tutorial, we are going to discuss on the concept of tree that is represented by nodes connected by edges. So till now we were discussing on the linear data structures such as arrays and linked list, but tree is a non-linear data structure. So if we want to map it to a real world application, then you can think of geographical regions. Yeah. So in geography, we have, sorry, we have territory. Then inside the territories, we have multiple regions. Then inside the multiple regions, we do have district level details, right? So this type of hierarchy we can represent and store the data using the concept of tree data structure. Um, Looking to other examples, you can think of our file system. So in our devices, we have directories, right? So inside a directory, I can have a subdirectory or multiple files. So this kind of hierarchy, we make use of tree data structure. So in this tutorial, we are going to discuss on binary tree. Uh, and what do we mean by calling a tree as binary tree is each node can have a maximum of two children. Okay, I would like to explain by using a diagram. Okay, so this is my tree data structure. The first node, which is the top of the tree, represents the root. So every tree has one root. This is my root node. Then the other important term that I would like to mention is parent-child relationship. So this is the parent for node 1 to 2. Okay, I'll just put this is the parent node and this is the child node. Okay, so we are good with the root node, parent node, child node. Then we have, this is my leaf node as well. So a leaf node is a node which does not have any child node. So this is not having any child node. Even this is not having any child node. So though I have put it as my child node, I will put it here. This is my leaf node. Similarly, this is my child node. And let me put it as leaf node also. Okay. Now there is one more concept, that is levels. So here what do we mean by level is uh, basically a level of a node represents the generation of a node. So the root node is at level 0. So my first node, which is the root node, is at level 0. And if I'm generating more nodes, then this is at level 1. So this level is level 1. Then I'm generating more nodes. That is my 1 to 2. So that is the next level, right? So this level is level 1 plus 1, that is level 2. So we understand what do we mean by root, parent-child relationship, leaf node, and the levels of the tree. Now, okay, we have stored the data in the tree. How are we going to traverse through it? So we have three traversals. One is pre-order, second in order, third is post order. So what do I mean by pre-order traversal is, first I'm going to check the data at root, then the left node, then the right node. So if I check this particular tree itself, then my root left right. My pre-order traversal is 10, which is my root node. Then I'm moving to 11, the left. Then again the left node, 1 to 2. There is no right node, so I'm again going back to 11. There is no. Then going back to the root node. So I've already done the root traversal, the left traversal. So try the right node, which is 2, 3, 4. Okay. And in order traversal, what do we mean by it is, I am going to traverse the left node, then root, and then the right node. So the in order traversal for this particular tree is 1 to 2, then root 11, then again the root 10, and then the right node 2, 3, 4. Okay, moving on to the post order. So in post, root comes at the end of the traversal. So here it is my left, then my right node, then my root. So it is 1 to 2, then there is no right node, moving on to the root, which is 11, then root. So we cannot traverse the root 10, right? Because it will come at the end of the traversal. So moving on to the right, which is 2, 3, 4, and then the root. Okay, so just briefing once again. My pre-order is root node, left node, and right node. So I'm going to check the root 10, then moving on to the left. Then I have to again print the value of root. Moving on to the left is 1 to 2. There is no right node. So going back to 11 to 10. Then I have already traversed the root and the left. Only 2, 3, 4 is left, which is the right node. So I have printed the right node. Similarly, you can compare and map the behavior of the rest of the traversal. Moving on to the hands-on activity. Here I am going to declare the structure of the tree. So I'm putting struct t node, where I'm going to put a variable for the data, then my left and right pointers. It's a binary tree, so I will have left and right child. And t node, because we mentioned, right, a binary tree can have max of 2 children, and if a node has no children, then it's a leaf node. Okay, so I'm going to just declare t node, where I'm putting the information, where data is x and my left and right is null. I'm going to uh, define one function display where I would be putting the three type of traversal that we discussed just now. So before doing that, let me create a tree in the main function. So t node pointer root node, which was 10. Yeah, sorry. Then the left, creating a new t node, 11. Then root left, and one more left I'm putting, which is new t node, and the value of 122 it was, yeah. And the root right, creating a new node and giving the value of 234. So I would be defining a function as display here. So node, whose return type would be the tree structure display, and I would be passing the root of the tree. So t node should. Before defining here, I'm just putting a call to this function, which is root display. Sorry. Now let's define this function. First, let's put it for the in order. Then we will do the pre-order and then post order. The first check would be if hroot is equal to null, then return null. Okay, if my tree is empty, then I'm returning the null value. Now for in order traversal, I am going to use the recursive call here. So in order traversal is left root and then the right node. So I'm going to call display with the left pointer. So hroot left and then say out the root data, right? And then call the display for the right subtree. So display hroot right. Okay, let's run this program. Okay, one semicolon issue. Set line 43. Okay, so structure definition. I forgot to put the semicolon over here. Let's rerun the program. Yeah, so this is the in order traversal. In order, I can see 1, 2, 2, 11, 10, and 2, 3, 4. Similarly, we am going to define the pre-order and the post-order traversal. So the pre-order is root, then left, then right. Okay, so I'm just going to put the CL and hroot data, right? And then I'm going to call the display function using the left subtree. So H root left, and then display H root right. Okay. Moving on to the post order, which is left, right, and the root. So here, just call the display with the H root left subtree, then display H root right subtree, and then I'm just printing the value of H root. Okay, I'll just comment these traversals as of now, and we'll check for the pre-order. Okay, let's check the pre-order. So pre-order is 10, 11, 1, 2, 2, and 2, 3, 4. Kind of sorted, we can see it. So sorry, that was my pre-order, yeah. So pre-order is, yeah, 10, 11, 1, 2, 2, 2, 3, 4. I'm going to provide the GitHub link of this code. You can modify it and play around this code to get comfortable with the tree data structure. If you have more concerns or you want me to touch on other topics related to it or other types of tree data structures, like we have binary search tree and so on, please mention in the comment sections. I hope you liked the video. Please subscribe the channel. Thank you.